and back to the tutorial for operating system. So this is a tutorial definitely helpful for whoever want to crack the university exams, GATE, UGC or any competitive exam. And please support our channel and check the playlist when you have doubt. Today we are going to see the topic called shortest job first scheduling algorithm with preemption mode. In the previous session I explored SJF with non-preemptive, and before the sessions I explained what is the difference between preemptive and non-preemptive and so on. Please kindly check the playlist. Let's go for session today. See, another name is SRTF for shortest job first with scheduling is with preemptive mode. Another name is called SRTF, that is shortest remaining time first scheduling algorithm. In this algorithm, there is a simple concept here you can easily get it. Here jobs are put in the ready queue as they arrive, but as the process with the shortest burst time arrives, the existing process preempted or removed from the execution, and the shorter job is executed first. So let's say the example here. You can see the example, you can get clarity. So in CPU there will be ready queue. Let's take the example of here. In the CPU we have a ready queue. The ready queue have a process called the P1, P2, P3, P4. Let's say the example you can understand here. Here let's have the arrival time of 0, 1, 2, 3. P1 having the arrival time 0, bus time 8, and P2 having the arrival time 1 and bus time 4, and P3 having the arrival time 2 and bus time of 9. At last P4 having the arrival time of 3 at bus time of 5. So preemption means what? Preemptive are removed as in the CPU there will be 4 processes there. First process will execute for some time. After that it will choose P2, and after that P3, P4. But otherwise, in this concept, you will choose which process is having the lowest burst time. Okay, what are the process given? Process 1, 2, 3, 4. Which process first start from P1 for a few seconds. After that, you choose which process having the lowest burst time. It will take it based on the priority. Here we see the example. Gantt chart will get understanding. We will get better clarity. Here, see in this one, we make the Gantt chart now. Here P1 is there. So P1, the P2 arrival time is 1 here, remember. P2 arrival time is 1. So here P1 first will start and execute for only 1 milliseconds by default. Okay. Then P2. P2 is what is the burst time of burst time of P2 is here 4. So P2 what is whenever see here the P2 burst time is shorter than remaining burst time of the process 1, remember. So here P1, so what happens the CPU P1 execute for 1 milliseconds, then CPU gives a chance to P2, so P2 will P2 complete the process, that means totally 4 seconds. So here 1 plus 4, 5 seconds. So now P2 will be executed. So P2 is because having the P2 have the burst time is 4, it will execute now preempted from the CPU. That means P2 is completion over. Completion is over. Then here, so here first remember here the P1 already 1 milliseconds executed now. The balance. So here the balance is burst time is 7. Okay, 1 milliseconds already executed by default. So balance 7 is 7. So now burst time of P1 is 7, P2 completed, P3 9, and P4 is 5. So now which is which processing lowest burst time? By default you know P4. P4 burst time is 5. So the CPU start to execute the P4 now. So P4 is 5, completion of burst time is 5, already 5 is there. So 5 plus 10. So whenever so totally P4 completion time is 10 here. So I already made the Gantt chart here. Now what are the left now? Now P4 is over. Sorry. Now P4 is already P2 executed. Now P4 is over. What are the remaining balance now? P1 and P3. Here P1 burst time is 1, 7, and P3 is burst time is 9. Which is lowest one? P1 is lowest one. So the CPU start to execute the P1. So P1 execution time is 7, already burst time is 7, already 10 is there. So 10 plus 7, 17. So P1 take totally 17 milliseconds to complete the process. So P1 is over now, completed. At last P3 is there. The P3 is burst time is 9. So already 9 here already 17 is there. 17 plus 9 26. So So at last P3 will complete at 23 milliseconds, 26 milliseconds, P3 will complete at, remember. So it is a simple concept where which process having the lowest bus time, it will be carried forward by it will taken by the CPU and completed. After completing, it gives the chance to some other process. What are the process? One process to any order based on the bus time only. Now completion time. So already told you completion time is what? The formula is completion time is bus time minus arrival time. Sorry. So completion time you have to write it. So completion time as P1 is what here? Totally 17. See the concept on right? 17. Then completion time as P2 is here 5. See in the concept. Then P3 is 26. At last P4 is 10. Now we can find the turnaround time. So turnaround formula is what? Completion time minus arrival time. So easy and simple. I am repeating here. So here I already calculated turnaround time, that is 17 minus 0 17, and here 5 minus 1 4, and here so 26 minus 2 24, and 10 minus 3 7 turnaround time. Now what is the formula for waiting time? So turnaround time minus bus time is waiting time. So here waiting time for P1 is 17 minus 8 9, and here for P2 4 minus 4 0, for P3 24 minus 6 9 15, and here for P4 7 minus 5 2. So now at last we can calculate the average turnaround time by the waiting time. So we are considering only four processes, that is P1 P2 P3 P4. there is no other new process here. Let's go for final stage, that is average wait time. So if you add this average waiting time, what is the total? 9 plus 15 plus 0 plus 15 plus 2, that is 26 by 4 number of processes. So 26 by 4, that is 6.2 milliseconds. Similarly, turnaround time is what? 17 plus 4 plus 24 plus 7, that is come 52 by 4. So 30 milliseconds totally. So like that you can calculate the SJF shortest job first algorithm with preemptive mode. If you have any queries or suggestions, please kindly comment with the social media. And thanks for watching the video. Please like, share, comment, and press bell icon for more updates. Thank you.